Hello everyone, this is Cameron Snow with Danomics.com. In this webinar, I'm going to be discussing some of the observations we have made around building and deploying machine learning models. At first, we're just going to talk about some of the general principles behind this and some of the observations that we've had as we've been interacting with companies. And then in the last part of the talk, I'm going to talk about how Danomics can help you deploy these models and how Danomics can really be part of your innovation pipeline. So with respect to what we'll cover in this talk, we're going to start off, we're going to talk about some of the observations we've made on implementing machine learning in oil and gas. Then we're going to talk about machine learning model development and then model deployment and how those differ. And then we're going to talk about how you can deploy your machine learning models with Danomics. So when you look at interest in AI and machine learning in oil and gas, there's a lot of different ways that you can measure this. You could look at, the size of data science teams that companies are building, or you could look at the amount of capital that's being allocated toward it. Unfortunately, those are difficult numbers to come by. Another way that you could look at that is by looking at the number of publications, and this includes both peer-reviewed publications and conference publications through time. And when you do this, what you see is that, in the early 2010s, so 2011 through 2013, 2014, there were definitely some papers, but not a lot. And then really sometime around 2015, the trend really started to take off, and we saw big year-over-year growth in the number of publications with respect to machine learning in oil and gas. And if the current pace holds up in 2021, it looks like we'll have over 7,000 publications on applying machine learning in oil and gas this year. And so I think that really shows the interest. And there's a reason for a lot of that interest, which is that AI and machine learning could be real game changers in certain areas for companies. When we look at how AI and machine learning are being applied, it's really hard to find an area that hasn't been touched by this technology in the upstream oil and gas industry. If you browse through LinkedIn or go to any conferences and sit in on the sessions for machine learning, you'll see a broad array of use cases. Where we have seen the most, of course, because we're a subsurface company, is on subsurface interpretation, whether or not that's seismic interpretation, identifying geobodies, well log correlation, petrophysics, which is where we put a lot of effort. There's also a desire to, in some cases, to see if you can use machine learning in reservoir modeling and production forecasting to try and get away from some of those compute-intensive physics-based models. And then even further downstream, you see it, with things like fluid slugging prediction and price forecasting. So, it's a technology that's starting to, reach out and touch many different aspects of the oil and gas industry. And this is something that I think we'll only see increase through time. However, I will say that, even though there's been a lot of interest in these type of machine learning solutions, when you look across the industry, the application of this technology has been somewhat inconsistent. And I think there are a number of reasons for that. So one of the biggest reasons is just skill set availability. As AI and machine learning have really came into their own in the past decade, we have seen very outsized demand for data scientists. And this was not a skill set that was traditionally located within the oil and gas industry. And so therefore, companies were kind of behind the eight ball when it came to getting a lot of these efforts kicked off. Another issue, and this is something that companies have been working on for a long time, is the availability and readiness of data. So specifically here, this is talking about moving that digital transformation where we move from, a lot of paper-based records into more digital records that are more suitable for machine learning. So that has been a big area of interest, but it's something that, once again, the oil and gas industry lagged on, especially some of the smaller companies in the space that didn't have the resources to dedicate to that. With respect to model development, there have been a number of efforts on this front. Obviously, every company has had some level of development on this, whether or not it was just done by, some interested scientists or engineers, or whether or not it was a true corporate effort. But a lot of times this has been hindered by the previous two. So, when you don't have the necessary skill sets available and you have suboptimal data, that really hinders your model development. And then something that I think all companies have struggled with is model deployment. So, and we'll go into how model development and model deployment are different things as we move through this talk. So when it comes to skill sets, we've really seen companies adapt and educate to this new machine learning paradigm. So companies have largely retooled their workforce in preparation for making data science and machine learning more integral to their business model. So we have seen a number of companies build new specialist teams that are focused on data science. If you look at any of the majors now, almost all of them have large data science teams, and you even see this down through a lot of the independents and into even some of the private equity-backed companies. You'll see a data science specialist embedded, and that is a complete 180-degree change from where we were at 5 years ago in the industry. Their companies have also done a lot of upskilling of their subject matter experts with data science training, and this really came from two sides. First of all, companies have recognized the need to increase data science skills, and they have trained their own subject matter experts on this. But also a lot of subject matter experts have taken advantage of these open courses that are online that can be accessed for relatively low price points and have upskilled themselves. So that has been a big change that we've seen. And finally, we have seen a continued emphasis on this digital transformation and moving people away from using a lot of the, let's say, more paper-based techniques into moving into more of the digital realm, and to really start, favoring the digital data over paper-based data. And when you look at the org charts of companies, it really reflects this change. It's very common now to see either a chief information officer, chief technology officer, chief data officer within an oil and gas company, where they will often have both the traditional IT realm, and IT may still be in charge of some of the data management, but where you now have specialist data science teams that are both embedded with and interacting with subsurface and operational teams. So you'll see a lot of cross reporting to up through the COO as well as to the CIO in this case. And once again, this is something that is very new in most companies. It's really flourished in the last few years, and it has resulted in essentially creating new branches and new departments within their business. The other thing that we have seen with companies is the thinking around data has really changed. So early on, companies, when they thought about their assets, they thought about their acreage base, their wells, their equipment, their facilities. Now data is included in that discussion. Data has really become an asset, and this is critical. If you have well organized data and good models for storing and accessing that data, that makes it a lot more useful and a lot more powerful, not only for machine learning, but for any of your subsurface workflows. Companies have also enhanced their data capture policies. It used to be that if you wanted to find certain data, especially data that's kind of one-off, like let's say PVT reports or maybe some well logging data, you would have to dig through network folders, ask people for it because a lot of times it was just stored in their email or on their desktop. And we've seen companies get a lot better at this and having a much more managed process. And then, once again, continued digitization. Whether or not it's digitizing reports with OCR technologies, scanning well logs, scanning seismic. There's been a big move towards that continued digitization. Okay, so with model development, now that a lot of these legacy data issues have been addressed, and now that upskilling of the workforce has been addressed, either through better training those subject matter experts or building up data science team, this has really unlocked model development, and we have seen a lot of really a lot of growth in this area. Companies have gone in and they have harvested a lot of that low-hanging fruit. Whenever you start a data science effort, there are just things that you have a good intuition that will work. You understand that there are correlations in some data, and you can go in and you can build, train, and test those models quite easily. And we've seen a lot of companies that they have churned through those projects and they have built internal systems that are quite robust. The other thing is obviously companies are very geographically focused, and we have seen companies build some very powerful localized and area-specific models or context-specific models, like let's say for a certain depositional environment. And that has really taken off. The only issue with these localized and specific models is, although they may prove that machine learning can be applied to a certain type of problem, is that they are very specific, and a lot of times they're not as transferable as one would hope that they could be. But nonetheless, we've seen impressive strides there. And when it comes to building machine learning models, the question is always, what is it that you want the result to be? There needs to be some type of answer or solution that you were training for. That could be something as simple as, I want to predict a well log. Well, that's easy enough. You've measured a sonic log. You want to predict a sonic log in another well. That's a fairly straightforward type of use case. However, as you move out to more complex use cases, this becomes more and more complex. So let's say, for example, you were looking at a reservoir model. What is it you are wanting your machine learning model to predict? Are you wanting it to predict production? Are you wanting it to predict pressure? Are you wanting it to predict the differential pressure between your grid cells in your model? There are a lot of different potential targets in that may require different models, and unfortunately, when you think about the answer, in a lot of cases, you are training to an interpretation. So someone has gone through and they've made an interpretation of what the pressure should be across an area, let's say, or what the production, the forecast production should be across an area. from a physics-based model, and now they want the machine learning model to replicate that. So you're having it replicate, in some cases, an interpretation instead of measured data. And so that often means that there is a bottleneck there. Okay, but regardless of your model development, one thing that people often tend to conflate is developing a model and deploying a model. And I just want to highlight that these are distinctly different processes. So when it comes to model deployment, that is when you take the machine learning that has been model that has been trained by your data science team, and you move it into an environment where users are going to be interacting with it, and that is when it is deployed. And there are a few key things that people need to keep in mind when they are deploying models. So if you want to have a robust solution that can be implemented across your company, that means you need to have some type of user interface for it that keeps your end users from having to go in and work with the code itself. They should be interacting with menus, drop downs, a visual interface instead of having to go into the code itself, because a lot of people are not comfortable with that type of environment, and you will not get good uptake if they feel like they have to go into that type of environment. And deploying AI and ML models, to build out that user interface, to build out those interactions, that requires software development and data engineering skills. And those are often very different than the data science skill sets that you're looking for to develop models. So it really creates a need for another career track within a company if you're going to both develop and deploy models internally. And to sum it up, basically here's a little cartoon for it, which is hey, we've got this model. How are we going to get it to the subsurface team? It's not my problem. You got to ask the software, the DevOps guys. And I think a lot of times it's that type of disconnect that leads to models being developed but not getting deployed. Okay, so let's spend a little more time talking about model development and how we view the workflow for model development. Okay, so the first thing to think about when it comes to developing models is what's the technology stack that your company is going to use. And it should be noted, this is very distinct from your typical subsurface technology stack. So when you're doing something like, let's say, an interpretation of a field, your technology stack may be, a mapping software, a petrophysics software, a reservoir simulation software, and maybe a handful of other associated softwares. When you are doing data science and building machine learning models, you're really going to be looking at a different stack. And here what we've highlighted is kind of everything that sits to the northwest of this dash red line is what a lot of your technology stack is going to be with respect to data science. You're going to be working with programming languages like Python and R. You're going to be using your IDE as your main piece of software, so something like VS Code or Jupyter Notebooks. You're going to be using a number of different libraries to help you both explore and visualize that data, so things like Pandas and Matplotlib and Plotly. And then you're going to be using external libraries for either Python or R, such as PyTorch or TensorFlow or scikit-learn. And so those are the technologies that you're going to be using. And these are also a little bit different. These are open source technologies. So unless you specifically go after an enterprise version of a certain piece of that technology, and there certainly are vendors out there that offer those, it's going to be a much different paradigm than when you work with your subsurface technology and you can just call up a helpline if you get stuck. You're going to have different resources available to your workforce here. And about the only commercial solutions that we really see in this quadrant are when you have things like Excel, Tableau, Spotfire, which are really focused on helping you visualize that data, filter that data, etc. So that's the technology stack that you're going to be looking at. Okay, when it comes to developing a model, here's the general workflow that we see. And as we go through this, I'm going to talk a little bit about who kind of owns each of these steps in the process. So we start off with the problem description, and this is something that often gets overlooked because people want to get to the point where they're building that model and working with the data, but it's very important to go into the problem description, where we go in and we say, what is our problem, what is the scope of this problem, and how feasible is it for us to address this? Feasibility can be on a number of issues. It can be on the feasibility of actually being able to model this with machine learning, but it could also be feasibility about access to data, or the complexity of it, how you're going to build out the user interactions, etc. And this really lies within the realm of the data science teams and the subject matter experts. They should be working closely in this phase to define the problem and understand the scope of it. Now, when it comes to data collection, this can fall on a number of different teams, but data collection, when we think about it in the oil and gas industry, this often means a combination of internal databases, vendor databases that you subscribe to as a company, public data that you may get from state agencies. And this is something that should really be part of your digital transformation strategy. This should involve not only your data science teams and your subject matter experts, but also IT and data engineering if you have that as well. And then when it comes to data cleaning, this is often where a large amount of time gets spent in model development. So there are a number of things that need to be done here. First of all, you need to make sure that data is available in common formats that can easily be imported and exported. Then you need to think about, what are the outliers? Do we have spurious data in here? And this is actually a very interesting area because, what may be an outlier to a data scientist in some cases may be perfectly acceptable to a subject matter expert. Let's say, for example, you were looking at at well production as a data scientist, and you see that something's making 100 barrels a day, and then it goes to 0 barrels a day for a month, and then it comes back up and resumes production, maybe a little bit of flush production, and their subject matter expert is familiar with oil and gas operations. They're like, oh, okay, the well got shut in for some reason. It was offline for a month, and then it came back, and we had a little spike when we had flush production, and then it resumed its decline. Where the data scientist may look at that and say, oh, here we have a big deviation from our observed data. This must be bad data. Let's alter this. Or if you think about looking at a well log, a coal seam that's 3 or 4 foot thick, you may look at that and as a geologist and say, oh, that's clearly a coal seam, that we expect the density log to be very low in this case. Once again, the data scientist may look at that without the context of years of subsurface experience, and they may erroneously view that as being an outlier in some way. So it's very important in what sounds like a very mundane step to have your data science teams and your subject matter experts define the boundaries of what is reasonable and what's an outlier and what's not. Then when it comes to data processing, excuse me, this is something that more falls in the sweet spots for data science teams. This is about truly preparing the data for machine learning models. So this is when you'll do things like potentially transforming or scaling your data, some type of standardization, which is often required for neural networks. Once again, they may want to interact with the subject matter experts, especially when you think about imputing missing data. Often the subject matter experts can provide a lot of very reasonable methods there. So that's an area where there should also be some collaboration, but now we're starting to move more into the realm of pure data science. And then at that point, then we start moving into things like data exploration, where we visualize the data, look at correlations between the data, try to understand, what the features are, how the features correlate to one another. And this should fall, squarely in the domain of most data scientists. And then we move finally into building the model. And one of the things I want to highlight here is that, by this point, you've probably already spent a month of time collecting, cleaning, processing, and analyzing the data before you ever build that first real serious model. And this part of the process is going to be where we deal with things like deciding on the algorithms that maybe are most amenable to this type of problem, testing a number of them, refining those models, tuning the hyperparameters, etc. And then we move into the model evaluation, which, once again, this is where your subject matter experts should come back into the process. And there are a number of things that are part of model evaluation. One of the biggest that I often see overlooked is understanding the benchmarking. What is our current state of the art? What is acceptable? What is a level of accuracy that creates value? So I think a lot of thought needs to be put into benchmarking. And of course, this is where you will hopefully continue to do some iteration and improvement on the model. So that's how we view the model development workflow. Okay, so once again, you've built that model. It seems to work. You think it's going to have impact. Your teams want to use it. Now what? And that takes us to model deployment. So let's start off by just what's the difference between development and deployment. So developing the model is what we just talked about. You go through that process of building and training a model, and that's really, in a way, it's kind of like doing lab work. If you think about that as an analogy, you're doing something very carefully. You're often doing it in a very manual process. It's very high touch. You're in there, you're with the code, you're, manipulating the data manually. You're trying to build the process that you'll be using. Whereas with model deployment, that is when you take that model out of the lab and move it into the real world to see how it actually performs and to let users start to interact with it. And there are a number of different kind of paradigms to this. So, when you think about on the model development side, you're collecting your data. But once you've deployed it, you won't data to just stream in to this model. You don't want to have to manually collect it. You want to be able to push that data into the model. With development, you spend a lot of time on data analysis, exploration, and cleaning. Once you deploy that model, you want that process to be automated. You want a data pipeline to be there to make sure that all your data is treated consistently before it goes into the model for prediction. When you're doing development, it's not uncommon to have to do a lot of manual debugging, to have to clean data sets in very specific ways, format specific data, etc. Once you have deployed it, you want your data pipeline plus your model to be able to handle those edge cases that may make your development code crash. You want to make sure that you have proper testing infrastructure around that, so you can test what happens as you put different types of data into the model. And in development, the data scientists and subject matter experts are going to be interacting with the code, modifying the code, etc. With deployment, it needs to have a user-friendly graphical interface available for the user, and that is the real difference. So while model development lives squarely with your subject matter experts and your data science teams, model deployment is really the domain of your data and software engineers. Those are different skill sets, and those are two things that often get conflated, and I want to make sure that we understand the differences. Okay, when we think about model deployment and the technology stack, once again, we are going to be using some of the same technologies, but we're also going to be using some different technologies. So, being able to access and move data around, that is going to require using services like Amazon Web Services, Microsoft Azure, Google Cloud Platform, etc. So you've got your cloud hosting and service provider. Sitting on top of that technology, you are going to have a lot of things like your database technologies, whether or not you're using a SQL or NoSQL database, whether or not it's something like Postgres or MongoDB or Apache Spark. There are a lot of different ways you can store your data, and your data engineers and your software development engineers should be making that decision, because they're the ones that need to be able to work with that and understand the data access patterns. And then as you start to move into deployment and software development, you're going to be working with a lot of front-end technologies. That could be things like React, Angular, Node.js, to help put a user interface on this data. And a lot of times you'll even have a big change in the code that's being used. So a lot of times machine learning models are developed in Python or R, but often for deployment, those models are rewritten in either C or Java. And the reason why is those languages have better performance profiles. And so we often see that if you want to have a nice smooth interaction, that you'll need to see development in a different language. And one thing here is that if you're an oil and gas company, you don't expect your geologist to design your drilling program. So don't expect your data scientist to write your software program. Once again, I want to draw this clear line between developing your models and deploying your models and the skill sets that are necessary for that. Okay, if we revisit the model development workflow and think about it for model deployment and how that varies, let's take a look at this and walk through it again. once again, we have the problem description, and when we think about this in the software engineering context, this would often be the business logic layer. And this often lies in the realm, once again, of the subject matter experts and the management. This is going to be understanding what is the workflow that a user would go through to be in a position to apply these type of models. For your data collection, once again, this comes down to having a data pipeline where you access the data and you process that data in a very consistent way. And so as the process of data collection, cleaning, and processing that was done very manually in the model development phase is now all being handled by a software development operations team that is building in a data pipeline. So this will often be what's referred to as data engineering. But it's all about making sure that the data gets from where it is to the machine learning model. When we think about data exploration, a lot of that visualization is still important even once the model is published and out there. So what we need is a end user software tool. And once again, this will be something that your software development team will have to build out. And this will often be a quite iterative process where they'll need to work with the subject matter experts to understand the visualizations that they need. And then instead of building the model, because that model is already built, we need to serve that model. So that model needs to be sitting there ready to be accessed by the end users. And there's a couple of different ways this can be done. It can either be a domain software tool that can call that model, or some type of API that can easily be accessed. Once again, this falls on a development operations team, not on your subject matter experts, not on your data scientists. It's a different skill set. And then finally, instead of evaluating the model, you will be interpreting results from that model. And that's when you move back to your domain software, and you move finally back to the realm of your subject matter experts and management. So that is how we view the model deployment type of workflow. It's about understanding what the business need is, taking the processes outlined by the data science team, turning those into a consistent pipeline, and then giving the users access to that model so they can go in and build that. I really can't stress the data pipeline enough. I think that behind every great machine learning model is a great data pipeline. You can have a great model, but if you can't get data into it, that model is going to be useless. So you've got to have a very reliable data pipeline into your model. So the data needs to be accessed from, all the various sources with what I would say are visual user interface tools. The data pipeline needs to clean, transform, manipulate that data in a very consistent manner so that once the user specifies the data to be analyzed, it is treated in a very consistent manner and fed into the model correctly. And then the results need to be returned either in the expected format or back to some type of visualization platform. And so this data pipeline is really about getting the data from your data sources, making it easy to get that data, move it into the model, make that prediction, and then get it back to the interpreters. And a good pipeline is almost invisible to the end user. They don't need to burden themselves thinking about what's going on in the background. They just know they select this database, and then the records are pulled, the records are formatted and processed in a way that makes them compatible with the model, and the model generates the prediction. And then they can put their focus on understanding the results that are generated by that model and understanding how to create value from the model, as opposed to thinking about it from a software engineering perspective. So one thing I will say is when it comes to model deployment, user experience is key here. One of the best ways to make a great machine learning model fail is to make it extremely difficult to use. There are a few principles here. I personally think that end users should never have to touch code to run a model. I think that when possible, we should have a graphical user interface as opposed to working in command prompts. And finally, end users need a way to be able to interpret the results. And that can either be a standalone tool or integration with some of the domain technologies that your subject matter expert already uses. There's nothing that's more disheartening when you're given a new tool, but that using it is incredibly arduous, painful, and prone to mistakes. And that's what's going to happen if you don't give your subject matter expert something that looks and feels like a true commercial tool. Adoption is already difficult. And if you make that pain to reward ratio very high, you're going to lower the chance that those models get adopted and used, even if their performance is great. So, I've talked a lot about how model development and model deployment are different. I want to briefly touch on, as a company, how should you think about developing and deploying models in-house versus externally? Now, I think there is a lot of merit to internal model development. Build up those data science teams, have them interact with your subject matter experts. That's where your competitive advantage lies. With respect to internal versus external software development operations, I think there are considerations that need to be made. So when you're developing something in-house, this means you have to have the right people there. And for a lot of oil and gas companies, they do not have full stack software developers. So that means you have to create a new career track. You have to develop that talent pipeline. It's going to mean, forming new groups and new teams. And this is going to be quite the process for HR to manage. Whereas if this is done externally, the development talent is the responsibility of a specialized vendor. Do you want to have that talent inside the company, or are you okay with that being outside the company? When you're doing DevOps within your company, remember you're paying 100% of the cost of that. So whenever you want to deploy a model, you are paying 100% of the cost of the development of that. Whereas if you do this externally, especially if it is a commercialized product and not done in a proprietary manner, the cost of those DevOps can be spread over multiple operators. One of the things that often gets overlooked when doing in-house development is training and support. Obviously, if you're developing in-house software tools, you need to have training and support for those. Whereas if done externally, that will be part of the service that you are buying into. When you build a tool internally, it's often going to be highly specialized, and the workflow that you're using may be very specific to your company or very specific to the particular subject matter expert that was working with the development team. Whereas when this is handed off to an external developer who's trying to commercialize a tool, they're going to develop something more generalized so that instead of only being useful to one company, it's useful to many companies. So that's another consideration. And then finally, when you're developing in-house, your projects are going to be constrained by the scale of your internal resources. If you have one DevOps team, you're going to be able to work on one deployment at a time. Maybe if you have a larger team, maybe you can work on a couple of these. However, if you're doing your DevOps externally, it really comes down to what's your ability to manage contracts and relationships. That's where the constraint is then, because you could go out to 3, 4, 5 different vendors. And then finally, and this is probably something that a lot of you have seen if you're in management and you have worked on internal efforts to develop software before, is that if you develop something in-house, the business continuity is all about your internal process. And if a few key people leave, those internal products can essentially either stagnate or die. Whereas if it's an external commercial solution, that really falls onto the vendor to make sure that there's business continuity there. And if you're worried about that as a company, you can always address that contractually to make sure that you have access to that technology even in the event that they go away. Okay, so when we think about vendors and their place in the value chain here, I think there are a lot of opportunities for value creation when operators partner with vendors. So first of all, I think software development clearly falls outside of the skill range of most oil and gas companies. And by partnering with a vendor, the oil and gas company can focus on its competitive advantages. It can focus on its data, on its subject matter experts, on their integration with data science, and then the vendors can focus on, designing and building a product, a commercial product, which is where their skill sets lie. Most oil and gas operators already have a lot of skills in vendor selection and contract management. So those are things that are directly applicable when you're interfacing with a vendor to build out a solution for you. A collaborative approach where you're working with a vendor, and those vendors are often working across multiple companies, often provides broader access to innovations. So as a vendor, you want the ability to build a robust commercial product, and this often involves partnering with multiple companies. And then everyone gets to benefit from that at the end, from having a more robust solution. And then finally, commercialization really spreads out the cost of development and training and software updates and maintenance across multiple companies. If you develop a product internally, that you are bearing 100% of those costs on your own. Whereas if you develop this in partnership with a vendor with the goal of commercialization, that vendor can go find 3, 4, 5 other partners to help bear the cost of development, and then as they grow their customer base, that's going to help keep the cost of training and updates low. So oil and gas operations and software development operations are very different businesses, and they're separate for a reason. And so that's one of the reasons I strongly encourage companies to seriously consider partnering with vendors for software development and building out commercial solutions, as opposed to trying to develop internal proprietary solutions. And there's ways that, as a company, both technically and contractually, that you can protect your IP while still making sure that you can leverage your IP within these commercial solutions. Okay, so I finally want to dive into model deployment with Danomics. So first of all, what is Danomics? Danomics is a cloud-based subsurface interpretation platform. We have product lines in petrophysics, geoscience, and production analysis. And this is all integrated into one cloud-based platform where you can collaborate and share with your colleagues. With respect to data handling within Danomics, we handle a broad array of data types natively within the platform. So, for example, well log and well header metadata are native to the platform. Most types of geological and spatial data are available within the platform, production data, and then really any type of tabular data. So any data that resembles a spreadsheet, you can bring into the Danomics platform, and we can handle that natively. And we also have the ability for users to bring in arbitrary files into the platform that they can then access. Okay, Danomics also has a tool called Flows built into the platform, and the idea with Flows is that they enable a data processing and innovation pipeline. So flows are all about getting data into a suite of tools, being able to process those multiple data types, and then being able to deliver a result. We have a large suite of pre-built tools that focus on data management, data cleanup, certain data transformations. But most importantly, we also have a fully integrated Python environment that allows users to run their code in our platform. And we've even set it up so you can save and publish tools to your colleagues. For example, here, this is a Python tool that we wrote internally for demonstration purposes, where it has a full user menu on the front that's quite easy to find, access to a machine learning model developed in Python on the back end. And really all you would have to do to publish this to users within your company is just right click on this tool and say publish, and then it would be broadly available within your company. Okay, within Danomics, our workflow for model deployment, there's a number of different ways you can approach it, but in general, the way we like to think about it is, in most cases, your data scientists are still going to be working with externally trained machine learning models. So, if you're comfortable with, VS Code or Jupyter Notebooks or whatever tool you're using, go ahead and use that for writing your Python code, for developing your workflows for processing data, and then even training your model and exporting that. Then come over to the Danomics platform. We will, you can migrate that data processing code to Danomics, and then you'll be able to leverage Danomics data input-output capabilities. As far as calling your model, this can either be loaded as a file to Danomics. Of course, it's 100% proprietary to you. No one else has access to that. So you can either load that model, or you can call it. If you want to store it on your own server, you can access that via Python from Danomics. And then, like I said, you can one-click deploy this to users within your company. You just right-click on that tool, and you can send that out to your colleagues to use. Then when your colleagues want to use it, they will create their own flow where they will visually select the data that they want to process via drop-down menus. They will have access to the model that you have built. They will be able to leverage Danomics data pipeline capabilities, and then that tool will return to them results that they can visualize in the platform, and that we have made it very easy to export so you can work with in other platforms as well. Okay, so I just wanted to show you what an example flow looks like for a deployed machine learning model. So here on the left-hand side, these are the different flow tools. We start with a log input tool, and this essentially is a drop-down menu where you would choose a log database and perhaps filter that via the well API number. So Danomics retrieves that data from the database. We then have a CPI log calc block in here, and this allows you to leverage Danomics log processing and log repair capabilities, and this can essentially take your petrophysical interpretation and make all those results available to you. So it puts that data into the flow. Then we have the log prediction tool, and this is a tool that I wrote and shared with a colleague using the same process that our users would, where you can build out a simple menu. Each one of these menu blocks only takes around 2 lines of code to write. And this is essentially a TensorFlow model that this flow tool reaches out to. It gets that TensorFlow model. It takes the specified well log curves that are provided, ingests those in the model, and then returns a prediction, in this case for your sonic and your PE logs. And then finally, the log output block simply returns that back to the Danomics platform, where it is now in a database that's available for you to either work with in platform or to export. Okay, so just want to wrap up here. So companies have built out strong internal data science teams for model development, and as a result of this, we have seen a lot of advances, especially at kind of the R&D stage, where we're seeing conference papers and we're seeing peer-reviewed publications that are really highlighting the potential for using AI and machine learning in oil and gas. And as those models are being developed and matured, we need to keep in mind that development and deployment of these models are distinct skill sets. So, like I said, you don't expect your geologist to do your drilling program design. You shouldn't expect for your data science team to do your software engineering type of work. They are distinct skill sets, and that needs to be considered when you start building out these new models. As I discussed, I think there are a lot of challenges for trying to build in-house software DevOps teams. And there are definitely some risk and rewards to working with third-party vendors. But I think, for a lot of companies, the benefits of working with a trusted third-party vendor, whether or not it's Danomics or not, can be quite high. So it's something that I think really needs to be considered before trying to build out a new team. And then finally, from the Danomics perspective, we believe that our data handling capabilities and our ability to help you implement a robust data pipeline and then deploy your models can really help unlock your company's ability to innovate. So that is it for this webinar. If you have any questions, you can always reach me at csnow@danomics.com. And if you're interested in taking a look at the Danomics platform, please visit us at www.danomics.com. And you can either contact myself to discuss a demo, or you can even start a free trial, yourself just by clicking on the create account button. All right, I hope this was somewhat useful to you, and I appreciate your attention.